everyone. Welcome to episode 8 of Interview with Scientists series. We will be talking to Christopher Lee today. Chris is the co founder and CEO of BioBox Analytics, a data analysis platform for scientists and clinicians working with next generation sequencing. He was studying transcriptional regulatory networks using machine learning at U of T, or University of Toronto. In this episode, we will talk with Chris about his research, career transition, next generation sequencing, data analysis, and biobanks. Thank you, Chris, for coming on the show.
Thank you, Chinmaya. Pleasure to be here.
Our pleasure as well. Can you tell us something about your research before you started BioBox?
Yeah, it was some time ago now, but at the time, the lab that I was at when I was doing my graduate degree, we were working on pediatric brain tumors.
Okay.
And, I was really interested from, the transcriptional regulation side. Now, this disease is diffuse intrinsic pontine gliomas. This is a very lethal disease. There are no real therapies at the time, I don't think, to this day.
Yeah.
And our lab had amassed, a bunch of data. The PI that I was working with at the time was is still one of the leading kind of researchers in the space. And as I was working through this, working through the RNA-seq data, that kind of gave me the I guess, motivation to really dive deep into the sequencing side of things. I've dabbled in it before, in summer studentships and stuff like that. But here, I was able to kind of really dive deep and explore it. And at this time, around this time, it was when circular RNAs was like just emerging. So I was very curious if there was something going on at the transcription level of circular RNAs, and there was a new species of RNAs that weren't very well characterized, weren't very well studied. So it's kind of like green pastures, right?
Yes.
And I guess what I did find at the time was that, there are actually circular RNAs that were differentially expressed, that were achieving different outcomes, that were actually very specific to tumor subgrouping, stuff like that. So we're exploring if that could be a viable biomarker for disease, and seeing where that could take us. And then that's where I was working on before BioBox.
That's very interesting. So, what was one of your critical findings, or what was your critical finding during your PhD or your research while doing this?
So this one is actually very interesting. I guess to keep it short, the way that circular RNAs are produced, they're produced from normal transcriptional like mRNAs and other actual real transcript that are read off. But the problem is the moment you circularize it, you have to destroy a regular RNA to make a circular RNA. But the tricky thing is when you do sequencing runs, you're just using primer amplification, especially on like total RNA sequencing.
Yes.
So you can actually have these artifacts that are like false positives being contributed by your circular RNA. So that the interesting observation is how accurate truly is RNA sequencing right now if we don't adjust for these kind of events, right?
Yes.
But unfortunately, I never got finished working on that part of the equation. So there's a lot of good work left on the table that time permitting, I would love to go back and play with. Yeah.
So when did you decide to move away from the bench
and pursue kind of entrepreneurship?
BioBox? Yes.
Yeah, it's tough to kind of nail down specifically some event, but the feeling at the time when I made the decision to kind of take this leap of faith was, I was going to work every day, and I was one of the few kind of computational guys in the team.
Yes.
So it was a big lab. We had a lot of people in our lab, and everyone needs a little bit of bioinformatics here and there, right?
Yeah.
Sprinkled across, different projects.
Yeah.
And every day I would go to work and I would do my own thing, but there's always someone who was waiting on something from me or needed something from me, which is totally fine. I mean, that's the nature of research, right? We help each other out, we collaborate, we build on the shoulders of giants. That's what we do. But I kind of saw it from the other side of the equation. Imagine if you're a PhD student and you got that committee meeting coming up in three weeks and you need this analysis done. But we're talking about competing priorities. I got my own committee meeting, or someone else is busy with a grant. So they're waiting on someone else, and they kind of lose the sense of autonomy when the barrier here is computational tooling, maybe some kind of scripting. Yeah. And in all fairness, you can't expect people to pick that up in 6 months time when it takes years to develop those skills. So
Yeah.
when faced with this, I built I built a little prototype to kind of help out, a little tool for them. Um, and when it started to really resonate with our colleagues and other people that I was talking to, me and my now co-founders, we kind of got together and we looked at the equation and said, is this something that we can actually build an enterprise level software designed for scientists by people who know what they're going through? And can we kind of solve this problem? And at that point, we knew it was time.
Okay, that's quite interesting. So it's a product made by scientists for scientists.
Yeah, exactly. We joke around, we say but it's kind of true. We basically are building the product that we would have always wanted when we were on the bench, right?
Yes. So that brings to my next question. Like, what can you tell us a little bit about next generation sequencing? What is next generation sequencing?
For sure. Yeah. So essentially, before next generation sequencing as a technology came out, the way that we investigated, let's say, mutations or transcription output, we had to do a bunch of PCR, right? We had to do Sanger and stuff like that. But next generation sequencing is basically massively parallel Sanger sequencing, if you kind of think about it, right?
Okay.
So using this technology and the vendors who provide this technology, you're able to in one shot be able to get all of the information you need from the entire genome, read every single base, and even start quantifying, let's say if you were to isolate RNA, you can quantify levels of RNA. Now, this becomes extremely important because it's this giant Pandora's box where you can discover a lot of amazing information, sometimes groundbreaking information, stuff like, biomarkers, molecular subgrouping of disease, etc.
Yeah.
But the interesting thing is with this new technology and all this capability, it created another problem, which is, well, now you're managing gigantic data. You have to learn computing, you have to learn algorithms, you have to, learn all the little tools to even access that information and do analyses, right? So it's kind of what really boosted, I think, biological research today. You'd be very hard pressed to find any paper that doesn't leverage at least some data that was based on next generation sequencing, or perhaps they're doing it themselves.
Yes.
Yeah.
So you mentioned something about Sanger sequencing. So could you just briefly tell us what is Sanger sequencing?
Sanger sequencing.
Yeah.
Yeah. So it's, don't quote me on this, it's been some time, but you're basically, using primers to be able to pin down a certain area that you're interested in fragments, and you're reading them base by base.
Okay.
To kind of like, and using like fluorophores, you're basically able to stitch together, from this area to this area, I have AC, TG, whatever, right?
Yes.
To get a really refined, zoomed in look at exactly the sequence. So you're looking at variants, you're looking at mutations, those kind of things.
Okay. So is next generation sequencing data analysis very complicated to do manually or through Excel?
Yeah. So it's funny. I think we had a blog post about this on our blog, but basically I remember the day in my summer studentship, right? I showed up, and then my PI at the time was like, your job this summer is to do bioinformatics. And I had no idea what that meant at the time. So I was like, yeah, sure. I do bioinformatics. Great. But then you start diving into it and you realize, to even begin, right, you need to play with data. Okay, now I got to figure out how to use the terminal on my computer. I have to learn how to code. And then, okay, now I know that part. I've solved, that first barrier. Oh, and now I have to learn this programming language. Now I have to learn that programming language. Now I have to start installing the software. Oh, wait, I need a computational server to do this. So I have to figure out how to access that. So it's layers and layers and layers of this stuff that's, really the prerequisite to even start playing with the actual data analytics side of things, to begin experimenting and iterating and really thinking deeply about the data. And unfortunately, we right now don't have a lot of tools to really support that side of things, which is, you either pay a lot of money to a fee-for-service team, maybe it's in your institution or in your hospital, or you rely on, some computational guys in your team, or collaborate, right?
Yeah. So if I want to start learning bioinformatics and the level of analyzing data for next generation sequencing, where do I start from for a beginner? I don't have a bioinformatics background at all. I'm a wet lab scientist. So if I want to do that, so where should I start?
Yeah, so that's a great question. Now, from what I've heard, right? I've never like done them formally, but there's great courses, kind of like boot camps that will teach you the
Okay.
fundamentals of this. Like I know Cold Spring Harbor has a 2 week, like a week long course that you could take.
Yes.
That's like, really condensed, teach you the basics. And then after that, really, I think if you ask most kind of bioinformaticians, a lot of it is trial and error, self-discovery,
Okay.
figuring it out, and learning. But having that foundation, you could definitely do that by going to one of these courses like Cold Spring Harbor.
Yes.
And there's actually a lot of services that you could tap into to at least learn the programming side of things.
Yes.
Even YouTube videos, really, like that's kind of where I started too.
Uh-huh. That's
Yeah.
that's very interesting because I
You
never
gotta
thought of doing that.
you gotta really be into it to like kind of
Yes.
dive, because you're like learning a whole new discipline, right? So,
Yes.
but
And
it's
it
very
will.
rewarding.
Okay.
Yeah,
So
it's
it will
very
take
rewarding.
a lot of time, I suppose. Learning. The learning curve would be very steep for someone like
Yeah,
you.
and it's definitely something like if you're a grad student just
Yeah.
starting out, if you're like, in that lull in the first year where you're trying to like
Yes.
clear up like what your thesis is, like that's the best time, right? If you're
Okay.
first year in your master's and you have some time,
Yeah.
try picking it up, try learning stuff on the side, right? But if your defense is coming up, like I wouldn't recommend it.
Of course. Then you will diverge away from your thesis defense into something else.
Yeah, yeah.
So, what exactly is BioBox? I just briefly mentioned about it, but maybe you can explain more. What is
Yeah.
BioBox?
So, like you said, BioBox, we're building a web-based platform, a data analytics engine, and a platform designed to support scientists in research from start to finish. Right?
Okay.
You bring your data into the platform. You can run computational pipelines without having to learn code.
Yeah.
You can create publication-ready plots. You can use some of our discovery engines to look up additional metadata, perform some insight discovery, kind of get a lot of I guess the system kind of supports you as you're doing your research.
Uh-huh.
And really what we're trying to achieve here is we know that, research is the product of many different collaborators, right? We have
Yes.
a lot of people in big scale projects, but the problem is it results in a lot of decentralized data and with
Yes.
with too many moving parts, right? And this slows down our research projects and it
Yes.
shortens everyone's bandwidth to really, to maximize our research time, because the things that we're doing in research, it's meaningful, right? There's
Yes.
some disease that we're looking for a treatment. There's some fundamental biological questions we're trying to answer, and time is always of the essence.
Yes.
So what we're trying to focus on is, instead of data being fragmented, right,
Mhm.
we organize it, we make it accessible, we make it searchable, no code required. You don't need to learn how to figure out, managing a server, right? And at the same time, making this data easy to play with, right? Be
Okay.
it visualization, be it discovery, be it just data mining, and
Yes.
have all the tools in this platform so that you can kind of catalog your work and build your thesis and kind of get to that publication faster, get to that defense faster.
Yes.
And we're building it so that each lab is able to grow their tree of knowledge internally, right? So that you can kind of build on top of what other people have done in the past,
Yes.
and to really accelerate and help accelerate what scientists are trying to do.
Okay. That's very interesting. So, if I summarize everything, I can say that it will make everyone's life easier while
That's the goal.
analyzing data.
That's the goal, yeah, and,
That's the
and
goal.
kind of
Yes.
push the tempo, and provide. We like to say, we only the scientists can kind of, we can't row the boat for you. Only you can,
Yes.
right? Like no
Yes.
one knows that area of research better than you. But what we can do is at the very least provide you with the best oars, the best boat for you to get to where you need to get to.
Of course. Thank you. So, this is for budding entrepreneurs. What are some advice that you want to give to budding entrepreneurs, or for those who want to start their own company or
Hmm.
move from academics to industry?
From academic to industry, yeah.
Industry.
So I guess the most important thing. There's a few things, but the first thing that comes to mind is to really start like collaborating more. We collaborate at like quite a bit in research, but to really kind of even ramp that up. Now, I'll tell you why.
Yes.
And I'm sure you can identify with this too. When we start getting into the weeds of our project,
Yes.
you can go for like weeks, maybe months without talking to another person because you're so locked in, you're so, focused, but then you kind of silo yourself away, right? And it's great for deep focus and deep work, right? But the problem is when you want to jump into entrepreneurship, that
Yes.
kind of siloing doesn't happen anymore. It can't happen, right? I mean, compared my life back then when, like I said, I could go weeks without talking with another lab member. But now every day I have to interface with my team. Every day we're kind of synced up. Everyone's kind of trying to move in the same direction, and there's a lot of
Yes.
coordination. So learning how to work in team environments consistently, participate effectively, communicating effectively. The
Hmm.
best thing that you could do right now in academics, if you're thinking about making this switch, is try jumping on to other collaborations, getting involved with your colleagues' research,
Yes.
and see if you can contribute or develop with them, just to learn those soft skills that become so critical when you
Yes.
jump into entrepreneurship.
Okay. So, if you were to interview someone right now, who just completed his PhD, what questions would you ask him?
For if they were trying looking to join
Wow.
BioBox, yeah.
Yeah.
Oh wow, that's a great question. Well, I think the most important thing, and I think something that really kind of keeps our team going is the why,
Yes.
right? Um, After finishing your PhD, you could be doing a lot of things. So why are you looking to join BioBox? Like, do you resonate with our mission,
Yes.
right? Do you resonate with the goals that we're trying to do to achieve here? And having a really strong why about why you want to participate in not just BioBox or any venture, really any startup. Um, Definitely, that conviction is the first thing I want to know when I'm
Okay.
interviewing. Yeah.
Okay. So, for every candidate, it's not for just for BioBox, but for any company, they should keep in mind the mission of the company
Oh, absolutely.
and
Yeah.
focus their answer based on that.
Yeah.
Okay, that's a good point. And so, what more exciting stuff is coming on BioBox right now?
Yeah, so we have a lot of things that were coming down the pipe. One of the most exciting things that we're interested in doing is, well, one, we're expanding our organism support. Well, we're speaking
Okay.
to some of our clients and some people who want to jump on the platform. But right now we have human data, support for human research. But
Yes.
then, as you know, definitely we need to start supporting model organisms, and we're looking to kind of bring on more and more model organisms to kind of diversify and be able to support a larger audience.
Okay.
But in terms of what we're really excited about in the coming days is, um, we have kind of this graphical interface to be able to compose pipelines, compose
Okay.
computational, really advanced algorithms that you want to run without
Yes.
having to write code. Now we want to kind of see where we can take this in the future and seeing, how much more customization we can put into this what we call the pipeline studio.
Yes.
And we're putting a lot of effort into our knowledge engine to be able to help data discovery, right? To be able to ask it a question, it can dig through your existing observations to answer anything that it could find, or maybe draw upon public data and public insights to help enrich that process. So
Okay.
really excited about that coming out. And in the next few months, we'll probably be looking to release those.
Okay. And when can people or researchers start accessing BioBox?
Yeah, so right now you can join the wait list, and the first I don't know the exact number, but the first wave we have a certain limit of seats that we can provide.
Yes.
You can jump on https://biobox.io and join the wait list, and as soon as the platform becomes as soon as platform is released,
Yes.
on the wait list will be contacted to get their exclusive access.
Okay. So my next question is about some advice for people who want to do a postdoc, but at the end they want to end up in industry. So is postdoc very important after a PhD to get into industry?
So I mean, I'll speak from what I've heard and what I've spoke with other colleagues that have made that jump, because I've never done a postdoc.
Yes.
And from recently, I had a colleague of mine, a good friend of mine, who actually recently made that transition.
Okay.
And one of the biggest kind of questions that during the interview process that she was telling me about from her experience is, it's funny, they ask you for, do you have industry experience? I'm like, well, no,
Yes.
like, I'm coming for the industry experience. I'm coming from academia here, right?
Yeah.
You bring a lot of specialized expert knowledge, right? Um, but at the same time, they're also looking like, have you worked in industry? Do you have any experience? And I think if I were to, hearing from what she was saying, some of the advice I would give is there are actually a lot of grants and fellowships that you could participate in that are academic industry partnerships, right? So in Canada we have like things like NSERC Alliance, MyTax. These are programs designed for academics to be able to work full time at a for-profit or industry kind of environment, and
Yes.
they're still like the work that they're doing is still, you can still earn your degree, you can still get your paper published, but you're working in that full-time environment, in the industry environment, and that goes a really long way when looking to make that jump, right? Because you
Okay.
have that experience, and even not even just having that on your CV, but just having that experience in general, and
Yes.
the lessons you learn, right?
Okay.
Yeah, so I definitely advise looking into any government programs that do academic industry partnerships.
Thank you. So, apart from BioBox and doing research, what are your hobbies? What do you enjoy the most?
Um, wow, there's a lot. I mean, let's see. I guess I dabble in some video games here and there, but
Okay.
I try not to let that take up too much of my time. But it's important to have some kind of outlets like hobbies, like some kind of things to
Yes.
just focus away from work for a little bit. Especially when I'm working from home 24/7, the same four walls. But beyond that, my dog keeps me plenty busy.
Okay.
Got a big German Shepherd, so I got to walk her all the time. So that's pretty much my hobbies. Between BioBox, playing with my dog, and spending my free time just relaxing and trying to de-stress.
I concur with you. I also have a dog, a beagle, and I love playing with him.
Yeah, yeah, it's unbelievable like how much time I've been able to spend with her now that I've been working from home for I don't know how long, almost a year now, right?
Almost a year, yes.
Yeah, so it's that's, I guess, a silver lining.
Mhm.
Yeah.
Thank you very much for joining us today, Chris, and sharing your suggestions and telling us more about BioBox. I personally learned a lot, and I'm sure our audience would have definitely learned from you as well. Thank you very much for your time today.
Yeah, thank you for the opportunity. I really appreciate it, and it was a pleasure speaking with you, Chinmaya.